Okay, 1, 2, 3 testing, 1, 2, 3 testing. This is a presentation of the temperature benchmarks of the MORAD 360, and I'm going to do this as fast as I can. These are the two radiators I currently started with the EK CoolStream 360 with 3 EK Furious Vadar fans that run up to 300 RPMs. And I've now replaced this radiator with the MORAD 360 with, it runs 9 dark side fans that run up to 1850 RPMs. These are the two contenders. The water loop that I have for my Franken loop, it's basically a parallel water block design where all water blocks are in parallel with the water flow. And I have 2 temperature sensors, one on either side of the radiator. So what I call the hot water bus temperature sensor measures the hot water, and then the radiator cools it. And on the cold side, we have the cold water bus temperature sensor. All other temperatures are measured directly from the devices, which are basically the 2 GPUs and the CPUs. This is a typical graph of how I collected the data. And let me walk through this graph very quickly so you can see what measurements I'm actually presenting in the final benchmarks. We start with the bottom one. This red plot is the temperature difference between GPU 0 and the cold water bus. And the second one in magenta, which you can barely see, that's the temperature difference between GPU 1 and the cold water bus. And finally, in black, we have the CPU temperature minus the cold water bus. Here in blue, if you can see it, and in orange are the actual cold and hot temperatures. And you can see in this particular configuration, this is with the EK radiator, there's very little difference between the cold and the hot, and it's very hard to discern the two. But you can see the rise. So this is running the Tomb Raider benchmark in this one. This is when I started playing Tomb Raider, and I played for about 10 minutes, and this is when I ended. And it takes about 10 minutes for the water in the water loop to reach equilibrium. And you can see in this case, the water temperature went from 25 degrees up to 32 degrees for this particular run. And then what we have, so those are the 2 temperatures. This is the temperatures of the water. And then we have in red, this is the actual, just the raw GPU 0 temperature. This is the raw GPU 1 temperature. And this is just the raw CPU temperature. And you can see basically the difference between this and this is what you see down here. Okay. All right, so what I'm going to present is various configurations of running the fans at full blown, and then sort of the full blast, and then the fans at fan level, which I consider to be quiet, and respectively quiet so you can play a video game without being annoyed by the fan noise. And I do that for both the old radiator, the EK radiator, and for the MORAD radiator. And then I did 2 benchmarks. One is Tomb Raider, just me getting on Tomb Raider and playing Tomb Raider. And then the other one is running the 3D Mark Port Royale stress test. And the Port Royale stress test is the one that generates the most power. Typically, the actual power for the whole computer, the power being drawn by the power unit, is about 800 volts or 800 watts. And then the reason I use Tomb Raider as the other benchmark is that's the only video game which actually stresses the 2 CPUs. So these are the 2 GPUs. Anyway, so here's the first set of plots. Up here, you have the old configuration, the EK CoolStream fans running at 100%, the CoolStream fans running at 50%. So this is noisy fans, quiet fans with the EK radiator. This is noisy fans, quiet fans with the MORAD radiator. And here the big difference is when I run the fans in quiet mode, there's clearly a very large heating of the water by almost 15 degrees or so. And then finally, the GPU1 ends up running at almost 60 degrees. So, so that's one of the motivating reasons why I decided to get the MORAD. And down here, when you look at the MORAD and then again, this is the theRigTempBenchmark Port Royale test. You can see that the difference between the noisy, sort of full-blown fans and the quiet. Here I run at 100% fans, so power them up at 100%. Here I'm only running at 45%. There's hardly any difference in the temperatures. The other thing to note, it's very hard to see, is you can actually measure the temperature difference between the hot and the cold. There's about a 5-degree difference between the hot and the cold. Well, I don't know if it's 5 degrees, but there's clearly a measurable difference between the hot and the cold when you're on the water bus. Okay, so this is the data for Port Royale. This is the data for Tomb Raider. Again, you can see big difference between noisy fans, quiet fans. So you want to run in quiet fan mode, but things get heated up. And with the MORAD, it's basically it's hard to tell the difference between the noisy and the quiet settings. And then all right, and this is just to show you what the power draw is for the GPUs when I run the 3D Port Royale test. Well, that's just a little side. So this is the final data comparing what the benefits you get when you switch from the EK 360 radiator to the MORAD 360 radiator. And I'm just going to point to this right here. So this is a theRigTempBenchmark Port Royale stress test. So GPU1, so the hottest it got was in 60 something, maybe 64 degrees. When you switch over to the radiator, you're now running down below 50 degrees. The other sort of so there is, I don't know, 15 degree sort of, there's a 15 degree improvement in the temperature. The other takeaway is if I run the fans at full blast with the 360 radiator, you get roughly the same temperatures as you get when you run the MORAD. Either in full-blown mode or in quiet mode. And so here you see the difference between the full and the quiet, and you see consistently there's just a small little temperature difference between the full and the quiet. And when you're running quiet mode, you're slightly better than running the EK 360 radiator in full-blown noisy mode. And so this is the theRigTempBenchmark Port Royale, and this is the Tomb Raider. This is for the Tomb Raider. Again, the same. You sort of see the same issues here, where the gain is now only about 10 degrees because you're not stressing the GPUs as much as you do with the Port Royale test. Now, one thing that I got a bit hung up on is if you look down here, there's a clear difference between the delta. So this is the water temperature of GPU 0, okay, sort of minus the cold water. And there is a difference that you go from the EK 360 radiator when you go up to the MORAD radiator. So the actual temperature draw is worse. So the effective cooling that you get at the water block level gets worse with the MORAD. So there's a few degrees. So clearly something like 4 to 5 degrees, maybe 4-degree difference. But I guess you make it up because there's like a 15-degree difference or a 10-degree difference between running the 360 in quiet mode versus just running the EK360 in quiet mode versus running the MORAD in either the quiet or the noisy sort of full out mode. So in the end, you actually do gain, but there are a few degrees that you can actually gain back if you could increase the water flow. So my big issue right now is the water flow, and I don't have this written down or don't have a slide on this, but the water flow through the loop was about 450 liters per hour when I had the EK 360 radiator. When I switched to the MORAD radiator, the water velocity, the water flow dropped to 200 liters per hour. And so that's the reason, I'm assuming that's the reason why this water temperature, these guys run about 4 to 5 degrees, maybe 4 degrees hotter than these guys. So, and then I posted that, where can I get a more powerful pump? And everybody says you don't need a more powerful pump. And you know what? I think you guys are right. I don't really need a more powerful pump. If I'm just looking at the global numbers, if these guys go down by like 4 or 5 degrees, I go from 45 degrees, maybe 50 degrees for the two GPUs down to 45 degrees. So it's just going to be a small change here. And most of the time when I play, when I'm playing Tomb Raider, these are the numbers that I'm getting. And when you play any other video game, as you're only using one GPU, so you don't drive the temperature as high. So I guess I'll just chill and just leave my system alone without actually trying to get a bigger or a dual pump system. Anyway, those are the results. I hope you guys enjoyed, or I hope this has been informative to you. Thank you very much.